Okay, let's see using the product rule for this x y squared. The first function is x. The second function is y squared. So we will have, well, we have to use the product rule. First d second plus second d first. Now remember, if we're finding dy dx, then what we're looking for is when the variable agrees on the bottom, we just take the derivative like normal. If it disagrees, like this, then when you take the derivative, you take it normally, but then you also just stick on a dy dx. So let's have that in mind while we do this. So the derivative of this would be product rule. First, meaning just the normal first function, times the derivative of the second. First d second plus second d first. So the derivative of 2y, well, the variable disagrees with what we're trying to take the derivative with respect to. So we have to do the derivative like normal. So I use the power rule to bring it down, and then I subtract 1 from the exponent, 2y. But then I also, since the variables disagree, I have to tack on a dy dx. So that's first d second plus second y squared d first. Well, the derivative of x is just 1. So a lot of the time I won't write the 1 because it's first d second plus second d first. The derivative of x is 1. So that's why the y squared sticks around right there. So the problem that you're having is when you take the derivative when they disagree, you take it like normal, but then you also tack on a dy dx. That's the main idea for implicit differentiation. You have to do it, take the derivative like normal, and then tack on a dy dx. The only reason, like if you take the derivative of y dx, well, the y kind of disappears and turns to a dy dx, because if you take the derivative like normal, the derivative of a single variable with no exponents, that's just 1. And then so you times it by, and then you tack on a dy dx. So that it's just the same thing as just dy dx. So that's why the y goes away when you're taking it when it doesn't have any like exponents or anything, but it doesn't go away when you do have exponents, because you're always doing the regular derivative and then tacking on a dy dx. The regular derivative here is just a 1. Hopefully that clears things up.